Hey there everyone, Ramesh here, back again with a new brand series, our course on Spring Boot and Apache Kafka. Well, this course is absolutely free because I am going to publish this course as a free on my YouTube channel. Well, this course is going to be a practical course. It means I am not going to cover a lot of theory part in this course. Though I am going to cover the core concepts and the terminologies of Apache Kafka, but I am not going to deep dive into the theoretical part of Apache Kafka. So you can go ahead and read the official documentation of Apache Kafka. So I am going to only focus on the practical part of this course. Alright, so in this course you will learn how to use Apache Kafka in a Spring Boot application. Well, this course is also useful to you if you are using event-driven architecture in your microservices. Let's say you are using Apache Kafka for the communication between multiple microservices as a messaging system, then you can go ahead and take this course so that you will understand the fundamentals of Apache Kafka and how you can use Apache Kafka in a Spring Boot project. Alright, so if you look at this architecture over here, microservices 1 basically produce the message and it will send that message to the Kafka broker, and microservices 2 will basically consume that message from the Kafka broker. Well, there can be a lot of microservices that can consume a message from the Kafka broker. Alright, well, in this course you will learn how to create a Kafka producer to produce the message and send to the Kafka broker, and how to create a Kafka consumer to consume the message from the Kafka broker. Alright, you will learn a lot of stuff in this course. Well, let's quickly take a look into what is Apache Kafka. Well, go to the browser and just type Apache Kafka and go to the official website of Apache Kafka over here. Apache Kafka is nothing but an open source distributed event streaming platform used by thousands of companies for high performance data pipelines, streaming analytics, data integration, and mission critical applications. Well, Apache Kafka initially built by LinkedIn, but later on it was managed by the Apache Foundation. Well, in order to understand more about Apache Kafka, let's take a look into how Apache Kafka looks in a nutshell. Well, if you can see, this is the Apache Kafka ecosystem. Well, as we know that Apache Kafka is a distributed system, so it acts as a Kafka cluster. Well, Kafka cluster is nothing but a cluster. It has one or more Kafka brokers. You can see in a diagram we have broker 1, broker 2, broker 3. Well, whenever you use a Kafka in a production, make sure that you at least use 3 brokers in a Kafka cluster. Alright, so here you can see producer and consumer. Well, producer is nothing but an application that produces the messages and send that message to the Kafka broker. Well, producer can produce any kind of message, like message can be an event, message can be a stream of records, stream of data, event can be arrow, plain text, string, JSON. Okay, so producer basically produce the message and it will send that message to the Kafka cluster. Alright, and then here you can say consumer. Well, consumer will basically consume those messages from the Kafka broker. Alright, so there is one more Kafka term, that is topic. So we basically create a topic in a Kafka cluster so that a consumer can able to subscribe to that particular topic. Well, here you can see one more important service, that is Zookeeper. Well, Zookeeper plays a very important role here. So Zookeeper basically manages the state of all these Kafka brokers. Okay, so cluster can contain a lot of Apache Kafka brokers, right? So there should be some way to manage the state of all these brokers in a cluster, right? So that is what the Zookeeper does. So Zookeeper basically maintains the state of all the Kafka brokers in a Kafka cluster, as well as Zookeeper maintains the configuration of all the topics, producer and consumer. Alright, so Zookeeper basically plays a very important role in the Kafka cluster. Well, this is how the Kafka ecosystem looks at a high level. Alright, so Apache Kafka is a distributed streaming platform. It means Apache Kafka can act as a cluster so that it can contains one or more Kafka brokers. And Apache Kafka, it is a fault tolerance meaning if one node or a broker goes down, then it can have a capability to manage the other nodes as well, because the data is distributed among different Kafka brokers, right? If one node or Apache Kafka broker goes down, then it has a capability to manage the entire cluster, right? Well, the data can be stored in Apache Kafka broker at any duration so that the consumers can able to consume the history data from the Apache Kafka broker. Okay, so these are the few important features of Apache Kafka. Well, let's take a look into some of the use cases of Apache Kafka. So here you can see these are the few popular use cases for Apache Kafka. Well, messaging. Well, as we know that there are some traditional messaging systems like ActiveMQ or RabbitMQ. So this Apache Kafka is works well as a replacement for these traditional message brokers. All right, and website activity tracking, metrics, log aggregation, stream processing, event sourcing, commit log. So these are the few popular use cases for Apache Kafka. Well, if you want to know more about Apache Kafka, then you can go ahead and read this introduction page. So this page will give you some brief idea about what is Apache Kafka and where you can use Apache Kafka. Alright, in next lecture I am going to cover the important key terminologies and the core concepts of Apache Kafka, so that it will be easy for you to understand whenever we use Apache Kafka in a Spring Boot application. Alright, I will see you in the next lecture. Hi, welcome back. In this lecture, we'll take a look into some of the important Kafka core concepts or terminologies. Well, in order to use Kafka in our Spring Boot application, we have to understand Apache Kafka core concepts or the terminologies. Well, in this lecture, I am going to go through some of the important Apache Kafka terminologies or the core concepts, so that it will be easy for you to understand how to use Apache Kafka in a Spring Boot application. Well, let's begin with Kafka cluster. Well, as we know that Apache Kafka is a distributed system, right? It acts as a cluster. Well, Kafka cluster consists of set of brokers. A cluster has a minimum of 3 brokers. Well, if you can see the diagram over here, Kafka cluster is nothing but it consists of set of brokers. It means it consists of one or more brokers, and it is recommended that at least you have 3 brokers in a Kafka cluster in a production. Alright, so just remember, Kafka cluster is nothing but it consists of one or more Kafka brokers. Now question is, what is Kafka broker? Well, Kafka broker is a Kafka server. It's just a meaningful name given to the Kafka server, and this name makes sense as well, because all that Kafka does is acts as a message broker between producer and consumer. The producer and consumer don't interact directly. They use Kafka server as an agent or a broker to exchange the messages. For example, if you can see the diagram over here, Kafka broker, it acts as a agent or a broker to exchange messages between producer and consumer. Alright, so just remember, Kafka broker is nothing but a Kafka server. It acts as a broker or an agent to exchange messages between producer and consumer. Alright, now the question is, what is producer? Well, producer is nothing but an application that produces the messages and sends to the Kafka broker. Well, producer does not send message directly to the recipient. It sends a message only to the Kafka server. Alright, just remember, producer is nothing but an application that produces the messages and sends to the Kafka broker. Producer don't send messages directly to the consumers. It sends message only to the Kafka server. Alright, now the question is, what is consumer? Well, consumer is basically an application that reads or consumes a message from the Kafka server. Well, if producers are sending the data, they must be sending to someone, right? The consumers are the recipients. But remember that producers don't send data to the recipient address. They just send it to Kafka server first, and anyone who is interested in that data can come forward and take it from the Kafka server. So any application that requests data from the Kafka server is a consumer, and they can ask for data sent by any producer provided they have permissions to read it. For example, look at here, we have a Kafka broker, and producer is nothing but an application that produces the messages and sends to the Kafka broker. And consumer is nothing but an application that consumes or reads a message from the Kafka server. Alright, now the question is, how the data is stored in a Kafka broker? Well, we learned that producer sends data to the Kafka broker. Then consumer can ask for data from the Kafka broker. But the question is, what kind of data? We need to have some identification mechanism to request data from the broker. There comes the topic. Well, what is topic? Well, topic is basically nothing but a category in a Kafka broker where the message is basically stored. For example, let's say producer is an application that produces the message or any data, and that data will be sent to the Kafka broker. And the data can be any format, like data can be a text, data can be a string, data can be a row, data can be a JSON, byte array. Alright, but when consumer consumes that data, there should be an identification mechanism in order to identify which kind of data. Alright, so in order to store the data format, we can use a topic. So topic is nothing but a category in a Kafka broker. It categorizes basically the messages or the data. Well, if you can compare topic with a database term, then topic is like a table in a database. Well, in database table, we store the records in a sequential manner, right? Similarly, in topic, we store the message in a sequential manner. Alright. Well, topic is identified by a name. Well, each topic contains a unique name so that consumer can easily, consume the data from that particular topic. You can have any number of topics in a Kafka cluster or Kafka broker. Well, you cannot query the message in a topic. Well, in database table, we query the data from the table, right? But in case of topic, you cannot query the data from the topic. The producer have to send the data to the Kafka broker, and the consumer have to consume the data from the Kafka broker. Alright, just remember, topic is nothing but a category that categorize the messages in a Kafka broker, and each topic has a unique name so that consumer can subscribe to that particular topic, and you can create any number of topics that you want in a Kafka broker. Next, what is Kafka partitions? Well, Kafka topics are further divided into number of partitions, which contains the records in an unchangeable sequence. Well, if you can see the diagram over here, we have topic 1. This topic 1 is divided into number of partitions, partition 1, partition 2, partition 3. And again, topic 2 is also divided into partition 1, partition 2, partition 3. Well, the idea behind a partition is that whenever Kafka brokers will store messages for a topic, but the capacity of the data can be enormous and it may not possible to store in a single computer. Therefore, it will be partitioned into multiple parts and distributed among multiple computers, since Kafka is a distributed system. Well, as we know that Kafka is a distributed system, so whenever we have a large amount of data, we can divide into partitions and we can distribute it among a multiple Kafka brokers in a Kafka cluster, right? So this is how the partitions looks like. So just remember, partitions nothing but a topic is again further divided into partitions so that a huge amount of data can be divided in among multiple partitions. Now the question is how the messages will be stored in a partition of the particular topic and how the message will be identified by a IDs. Well, that is where basically offset comes into picture. Offset is nothing but a sequence of IDs given to a message as they arrive at a partition. Once the offset is assigned, it will never be changed. The first message gets an offset 0, the next message receives an offset 1, and so on and so forth. Well, consider we have a Kafka broker, it has a topic and topic is divided into multiple partitions, and whenever Kafka broker store the message in a partition of the topic, then a sequence ID will be assigned to that message and that is called offset. Okay, for example, if you can see here partition 0, partition 1 and partition 2, and these are the sequence IDs given to the messages. Okay, and this is called a offset, and the offset ID starts with a 0, 1, 2, 3 like this. Alright, just remember offset is nothing but sequence of IDs given to the messages in a partition of a particular topic. Now let's take a look into what is consumer groups. Well, if you can see the diagram over here, we have my topic. It has multiple partitions like partition 0, partition 1, partition 2, and there are a lot of consumers are consuming the data from the my topic. And if you can see here, the consumers are again grouped here. Consumer group A contains these 4 groups, consumer B contains these 2 groups. Alright, so consumer group contains one or more groups working together to process the message. Well, just remember, consumer group contains one or more consumers working together to process the messages. Alright, so these are the important Apache Kafka terminologies or core concepts. Well, whenever we create Spring Boot Kafka project, then we are going to use these terminologies a lot. That's why I thought I could cover all these core concepts or the terminologies in this lecture. So let's quickly recap all these terminologies again. So Kafka clusters basically consist of one or more brokers, and broker is nothing but a Kafka server, and it basically acts as an agent or broker to exchange a message between producer and consumer. Producer is nothing but application that produces the message and sent to the Kafka broker, and consumer is nothing but application that reads or consumes the message from the Kafka server. Kafka topic is nothing but a category. It categorizes the messages in a Kafka broker, and we can create any number of topics in a Kafka broker, and each topic have a unique name so that consumer can subscribe to that particular topic. Kafka topics are divided into a number of partitions which contain records in an unchangeable sequence. Offset is nothing but a sequence of IDs given to messages in a partition of a particular topic. Consumer group contains one or more consumers working together to process the message. So these are the important Apache Kafka terminologies. Alright, great. I will see you in a next lecture. Hi, welcome back. In this lecture, we'll install and set up Apache Kafka locally. Well, it's pretty simple to install and set up Apache Kafka locally. Just follow the steps that I am going to implement in this lecture. Well, head over to the browser and in a new tab, just type Apache Kafka download and hit enter. So go ahead and click on this first link, that is download Apache Kafka. So this will navigate to the Apache Kafka downloads page. Well, here you can see get started tab, and within that here you can see quick start link. So go ahead and click on this quick start link over here. Well, in this course we are going to use Apache Kafka quick start page a lot. Okay, so just scroll down and here you can see the steps. So these are the steps are pretty useful to install and set up the Kafka locally. Well, let's take a look into the step 1. Step 1 is get Kafka. It means we need to download the latest Kafka release locally and then we need to extract it. So go ahead and click on this download link over here. Well, go ahead and click on this link to download Apache Kafka as a tar file locally. Well, I am going to click on this link. Kafka is downloading in a file system, so it will take a couple of seconds as per the internet speed. Well, once Apache Kafka downloaded as a zip file or a tar file, then go ahead and open in a folder and just go ahead and extract this file. So I am going to extract it. Now let's go and let's rename to this folder. So I am going to rename as Kafka. So just remove the version from here. Let's keep Kafka. Alright, now let's see the second step. So let me go back here, and second step is like we need to start the Kafka environment. Well, before starting the Kafka environment, make sure that you have installed Java 8 on your machine. Alright, next we need to start the Zookeeper. Well, you might be wondering what is Zookeeper, right? So here you can see the diagram, Kafka ecosystem diagram over here. So this Kafka ecosystem has a Kafka cluster, and within a Kafka cluster we have 3 Kafka brokers, Kafka broker 1, 2, 3. Alright, and here we have one Zookeeper. So Zookeeper is basically a service that will manage the state of all the Kafka brokers within a Kafka cluster, and it will also manage the configuration of topic and producer and consumer as well. Alright, so just remember we need to start the Zookeeper so that it will start managing the state of Kafka brokers in a Kafka cluster. Well, in our case we have only one Kafka broker that we are going to install locally. So first we need to start the Zookeeper so that it will manage the state of the Kafka broker. Well, in order to start the Zookeeper service, we need to execute this sh file, that is zookeeper-server-start.sh. Well, this sh file is located within a bin folder. If you go to Kafka, just expand the Kafka, and here we have a bin. Within bin folder you can see all these sh files. So these sh files will support for Mac and Linux. If you are using Windows, then make sure that you will use these bat files. Okay, so I am using Mac, so I am going to execute the sh files. Alright, so just search for zookeeper-server-start.sh over here, and there we go. So here you can see zookeeper-server-start.sh. So this is the sh file we are going to run in order to start the Zookeeper service. So just go back to browser and let me copy this command and let me execute in a terminal. So let me copy it and let me open the terminal over here and let me zoom this terminal and let me paste here. So before executing this command we need to move into Kafka folder, right? So just go ahead and type cd and then we need to move to the downloads folder, right? Downloads, hit enter, and within downloads folder we have Kafka folder, right? So cd Kafka and then we need to enter this command. So within Kafka folder we have bin folder, within bin folder we have this sh file and then config slash zookeeper.properties. Well, this sh file will refer all the properties from this properties file. Hit enter and there we go. You can see zookeeper service has started. Well, once zookeeper service has started, then we can go ahead and run the Kafka broker service. Well, just open a new terminal session and run this command. Well, let me copy this command. Well, if you can see this command over here, in order to start the Kafka broker service, we are going to run this sh file, that is kafka-server-start.sh. so this sh file is located within a bin folder. Well, let me go to Kafka again and within the bin folder you can see a bunch of sh files. So if you are using Windows, then you should use a bat file. Okay, so let me search for Kafka server start.sh file. So this is the sh file that we are going to run in order to start the Kafka broker service. Well, let me go back to the steps. Let me copy this command and let me go to the terminal. So if you are using Windows, then make sure that you use command prompt. Well, let me open the new cell. Okay, so let me zoom it a little bit. So if you are using Windows, then you can go ahead and open new command prompt. So let me go into the downloads folder, cd downloads, cd Kafka. Within downloads folder we have Kafka folder, right? So go to the Kafka folder and then run this command, that is kafka-server-start.sh file, and make sure that you provide this server.properties file. Okay, because this sh file basically refer all the properties from this server-properties file. So let me hit enter. So this will run the Apache Kafka broker service. Well, let me maximize this. Well, Apache Kafka broker service will run on localhost 9092. So let me just search for 9092 port and let me show you the log. It states the Apache broker service has started. Let me search for 9092 and there we go. So this is the log statement you can able to see. Recorded new controller. From now on we'll use a broker service localhost 9092, which means our Apache Kafka broker service is started on port 9092. Alright, and this localhost colon 9092 we are going to use in our Spring Boot application in order to interact with the Kafka. Okay, great. Now let me go back to the steps. Once all services has successfully launched, you will have a basic Kafka environment running and ready to use. Well, we have started Zookeeper service as well as Kafka broker service. Now we are good to use a Kafka broker service in our local machine. Well, let me recap what we have done in this lecture. We have downloaded the latest version of Kafka from the official website and then we have installed in our local machine, and then we have started Zookeeper service as well as Kafka broker service. Now we are good to use a Kafka environment in our Spring Boot application. Hi, welcome back. In this lecture, we'll create and set up Spring Boot project in IntelliJ IDEA. Well, we are going to use Spring Initializer to quickly create a Spring Boot project and then we'll import that project in a IntelliJ IDEA. Well, head over to the browser. I'm in a Chrome browser. In a new tab, just type start.spring.io. This will bring up Spring Initializer website. Well, Spring Initializer is a website or a web tool which we can use to quickly create a Spring based applications. Now let's fill up all the project information over here. Here you can see project type. We have two types of project, Maven project and Gradle project. So let's keep my main project as selected. And language, so here we have 3 JVM languages, Java, Kotlin and Groovy. We are going to use Java, so let's selected Java as it is. And here we are going to use Spring Boot version 2.6.7. Well, Spring Boot team basically recommend this stable and latest release of Spring Boot version, so let's keep this version as selected as it is. And go to project metadata section over here, and let's fill up all this project metadata information. So let's give group as net.java guides, and then artifact ID something like Spring Boot Kafka tutorial. Okay, and name is same as artifact, so let's keep name as Spring Boot Kafka tutorial. Description as demo project for Spring Boot and Kafka. Package name as net.javaguide.springboot. Alright, and packaging as a jar, and Java version 11. So you can use a Java version as 8, 11, 17, 18 as per the Java installation on your machine, but I am going to use Java 11 over here. Next, go to the dependency section and click on add dependencies over here, and just go ahead and select Spring Web dependency. Well, we are going to develop simple REST APIs, that's why we are going to select Spring Web dependency over here. Next, we are going to choose the Kafka dependency, that is Spring Kafka dependency. Well, here you can see Spring for Apache Kafka. Well, this is the dependency that is provided by Spring team to support Kafka with Spring Boot and Spring Framework. So go ahead and choose Spring for Apache Kafka dependency over here. Alright, so this is a very important dependency, guys. In order to support Apache Kafka in a Spring or Spring Boot applications, Spring team has provided this Spring for Apache Kafka dependency. Well, that is pretty much it. Now let's go ahead and let's generate this Spring Boot application as a zip file. So let's click on generate button over here. This will generate this Spring Boot application as a zip file. So now open this zip file in a folder, and let's extract this zip folder. So once you extract this zip folder, then open the IntelliJ IDEA. So I am going to open the IntelliJ IDEA over here, and here you can see a couple of options: new project, open, get from CVS. Well, we are going to open the existing Spring Boot project in IntelliJ IDEA, that's why click on open over here, and then go to the location where your Spring Boot application is downloaded. So in my case, in a downloads folder, and I'm going to choose Spring Boot Kafka tutorial project over here, and click on open. So this will open Spring Boot application in a IntelliJ IDEA. Now we have successfully imported Spring Boot application in a IntelliJ IDEA. Now let's go ahead and let's run our Spring Boot application just to make sure that our Spring Boot application is running properly. So I'm going to open this main entry point class. From here we are going to run the Spring Boot application, right? And there we go. Our Spring Boot application is up and running on embedded Tomcat server on port 8080. It means that we have successfully generated Spring Boot application from Spring Initializer, and then we have imported in IntelliJ IDEA, and then we ran our Spring Boot application, and we can able to see that Spring Boot application is successfully running on port 8080. Alright, great. I will see you in the next lecture. Hi, welcome back. In this lecture, we will configure Kafka producer and consumer in our Spring Boot application. Well, Spring Boot simplify a lot to configure Kafka producer and consumer in a Spring Boot application. Well, basically Spring Boot provides auto configuration to configure Kafka producer and consumer in our Spring Boot application. Okay, it means we don't have to write a Java configuration code to configure Kafka producer and consumer. Well, let's head over to the Spring Boot Kafka official documentation, and let's explore how Spring Boot will simplify configuring Kafka producer and consumer. Well, let me just type Spring Kafka documentation like this and hit enter, and just go ahead and click on first link, that is Spring for Apache Kafka. Alright, and go to the introduction section over here, and here you can see, so this is the dependency that we have added in order to integrate Kafka in our Spring application, right? So just scroll down, and here you can see getting started section. Well, if we don't use Spring Boot, then we need to write a lot of configuration code. For instance, just scroll down, and here you can see without Spring Boot we have to configure a lot of things, like we have to configure Kafka template, we have to configure producer factory. Okay, so here you can see we need to configure consumer factory, we need to set up consumer properties. Alright, so without Spring Boot basically we need to write all this kind of boilerplate Java configuration code, but Spring Boot simplifies all these things. Okay, so Spring Boot offers external properties that we can simply use in our application.properties file to configure Kafka producer and consumer. Well, just remember, without Spring Boot we need to write a lot of configuration code to configure Kafka producer and consumer. For example, we need to configure consumer factory bin, we need to configure Kafka template, we need to configure producer factory. Alright, we need to create a lot of configuration code in order to configure Kafka producer and consumer if we don't use Spring Boot. Okay, but Spring Boot simplifies all this configuration. Spring Boot by default configure all these bins for us. We don't have to write all this much of code in order to configure Kafka producer and consumer in our Spring Boot application. Okay, I hope you understood. Well, let's go back to IntelliJ IDEA. Let's configure Kafka producer and consumer. Well, let me go to the IntelliJ IDEA over here, and let's go to resources section and open application.properties file. Within application.properties file, we are going to configure Kafka broker server address as well as consumer and producer related configuration. Well, let's type the property spring.kafka.consumer. So first we'll configure consumer and then we'll configure producer. spring.kafka.consumer.bootstrap -servers. So this property basically we use to configure all the Apache Kafka servers. Right now we have only one Apache Kafka broker which is running locally, right? So let's provide the value as localhost : the port 9092. Well, right now we have only one Kafka broker service which is running on local machine, but let's say if you have multiple Kafka broker services running on your cluster, then what you need to do is you need to mention all those Kafka brokers separated by comma. For example, localhost : 9092, localhost 9091. Let's say if another Kafka broker is running on 9093, then you need to mention all these Kafka server addresses separated by comma here. Alright, now we have only one Kafka broker service which is running on port 9092. Next we need to configure consumer group. Just type the property spring.kafka.consumer.group-id. So basically we need to provide a consumer group where the consumer is belongs to. For example, let's say my group. Well, if you can head over to Kafka ecosystem diagram over here, we have a consumer group. It consists of multiple consumers like consumer 1, consumer 2, consumer 3, right? So we have to mention the consumer group ID in which the consumer is belongs to. So in our case, we are going to provide the unique group ID, that is my group. Alright, I hope you understood the usage of this property, right? So we need to provide the consumer group ID in which the consumer is belongs to. Next we need to configure offset for this consumer. So just type the property spring.kafka.consumer.auto-offset-reset, and then let's provide a value as year list. Okay, well, we need to specify this property because this property specifies what to do when there is no initial offset in a Kafka, or if the current offset does not exist anymore on the server. And here we have provided a value earliest because it will automatically reset the offset to the earliest offset, And there are a couple of values as well, like latest, none, anything else. But most of the time we use earliest. Okay, earliest. So this will automatically reset the offset to the earliest offset. Next we need to configure consumer key and value deserializer. Well, just type the property spring.kafka.consumer.key deserializer, and the value is org.apache.kafka.common.serialization.string deserializer. Well, we are using string deserializer class from Kafka library to deserialize a key in a message. So similarly, we need to use deserializer class to deserialize a value in a message, right? So let me simply copy this property and let me paste it over here, and let me change from key to value. Alright, so we are going to basically use string deserializer class from Apache Kafka library to deserialize a value in a message. Okay, now we have successfully configured Kafka producer using Spring Boot provided properties over here. Next we will configure a producer. Well, we are going to again use Spring Boot provided properties in order to configure Apache Kafka producer. Well, just type the property spring.kafka.producer.bootstrap -servers :localhost 9092. So for producer also we are using the same Apache Kafka broker service, right, which is running on port 9092. Next we need to configure a serializer class for key and value in a producer as well. Just type the property spring.kafka.producer.key-serializer and then org.apache.kafka.common.serialization.string serializer. So instead of deserializer we are going to use string serializer class in order to serialize the key in a message. So simply hit enter. So I am going to copy this and paste it over here in order to configure a serializer class to serialize a value in a message, right? And instead of key, just type the value here. Now we have configured serializer classes to serialize key and value in a message. This is pretty much it. So this is how basically we configure Kafka producer and consumer in our Spring Boot application using Spring Boot provided external properties. Okay, this is awesome, right? We don't have to write a lot of configuration code in order to configure Kafka producer and consumer in our Spring Boot application. Spring Boot will automatically provide a lot of auto configuration. Okay, so we have to just use the external properties in order to configure Kafka producer and consumer. All right, now let's go ahead and let's run the Spring Boot application and let's verify whether this configuration works properly or not. So let me run the Spring Boot application. Let me go to main entry point class, and from here I am going to run the Spring Boot application, and there we go. Spring Boot application is running on embedded Tomcat server on port 8080. It means this configuration, that is Kafka producer and consumer configuration in application.properties file is working as expected. Alright, great. I will see you in the next lecture. Hi, welcome back. In this lecture we'll see how to create a topic in a Kafka in our Spring Boot application. Well, in order to produce the messages and send to the topic, first we need to have a topic in our Kafka cluster, right? So if you can see the Kafka architecture over here, we have a Kafka cluster. Within a Kafka cluster we can create any number of topics that we want. Okay, there is no limitation. Basically whatever the topics that you want, you can go ahead and create in a Kafka cluster. Well, in our case we have only one Kafka broker service which is running on locally, so it acts as a Kafka cluster. So within a Kafka cluster we can create a topic, and if you can see a topic can be again split into multiple partitions. Alright, so we are not going to create the partition in a topic. So whatever the Kafka provides a default partitions that we are going to use in our Spring Boot application. Alright, so in order to produce the messages by producer and send to the topic, we need to have a topic in our Kafka cluster, right? Alright, head over to the IntelliJ IDEA and let's create a topic in a Kafka cluster using Spring Boot application. Well, let's head over to the IntelliJ IDEA here and let me minimize this and let me go to main package, and I'm going to create a new package over here. Let's call it as config. All the configuration classes that we are going to keep within this config package. So right click on config folder, new, and then choose Java class, and let's give class name as Kafka topic config, something like this. Okay, so basically we are going to create a Spring Bean to configure the Kafka topic. So let's go and let's annotate this class with @configuration annotation, so that this class acts as a Java Spring configuration class. So within this class we are going to create a bin to create a Kafka topic. So just type public and then new topic. So make sure that you choose new topic from Kafka clients.admin package. Let's give method name as Java guides topic, and within this method we are going to create an instance of topic class. So let's have a return statement over here, and let's use topic builder class from Spring Framework. Well, here you can see org.springframework.kafka.config. okay, make sure that you choose this topic builder class from this Spring Framework Kafka library, and then call the name API, and let's provide a name to the topic. In our case, let's say Java guides. Okay, so you can also split this topic into partitions. In order to do that, you can use partitions method, and you can pass like any number. Let's say you want to split this topic into 10 partitions, then you can go ahead and pass 10 over here. Alright, so basically we are going to use a default partitions provided by Kafka, so we're not going to create a partitions in this topic. So after that, just call build method in order to create the topic instance. Okay, that's it. Now let's make this method as a Spring Bean by using @bin annotation. Okay, that is pretty much it. Now we have created Kafka topic in a Kafka cluster using Spring Boot application. Well, if you can run the Spring Boot application, and you can see there are no errors, it means whatever the code we have written to configure Kafka topic is working as expected. Alright, I will see you in a next lecture. Hi, welcome back. In this lecture we'll create Kafka producer. Well, in previous lecture we have created a topic in a Kafka cluster, right? In this lecture we are going to create a Kafka producer so that we can able to write a message to the Kafka topic. Alright, let's head over to the IntelliJ IDEA and let's create a Kafka producer to write a message to the topic. Well, I'm going to create a new package for that. So let's right click on the main package, new, and then choose package, and let's give package name as Kafka. Okay, within a Kafka package we're going to create a class, and let's give class name as Kafka producer. Alright, hit enter, and let's annotate this producer service with @service annotation. Okay, great. Well, in order to send a message to the topic, we are going to use Spring provided Kafka template. Well, let's go and let's inject Kafka template in this Spring Bean. Well, basically Spring Boot provides auto configuration for Kafka template. We just have to inject and use it. For example, let's say private Kafka template. So this should be private and then Kafka template, and make sure that you choose Kafka template from Spring Framework library, that is spring framework.kafka.core package, and this is the generic, so we have to pass the key value here. So the type of the key is string and the type of the value is string. Okay, now let's provide a variable name, that is Kafka template. So we are going to basically use constructor based dependency injection. So in order to do that, let's create a constructor. Okay, now we have used constructor dependency to inject this Kafka template. Okay, so if you don't use Spring Boot, then we have to explicitly configure Kafka template. It means you need to write a code to configure Kafka template if you don't use Spring Boot. Okay, if you use Spring Boot, then you don't need to configure Kafka template, because Spring Boot will provide auto configuration for this Kafka template so that we can simply inject and use it, right? Great. Now let's go and let's create a method which will use Kafka template to send the message. So here I'm going to create the method. Let's say public void, and the method name is send message, and let's pass message of type string as a method argument. All right, and here let's use Kafka template dot send. So look at here, Kafka template basically provides a lot of overloaded send methods, right? We have to use appropriate send method. So in our case, we are going to use first one. It has type string topic comma string data. So go ahead and choose this one, and then pass topic as a post parameter. In our case, we have created Java guides as a topic name, right? And then second parameter as a message. All right, so if you can go to Kafka topic config class, you can see we have provided a topic name as Java guides. Now let's go to Kafka producer class again, and let's put a log statement in order to print this message. Well, let's use Spring Boot provided default logger to log the message. So here let's say private static final and then logger. So let's use logger from self4j library, and then let's give name as a logger equal to logger factory. So make sure that you choose logger factory from org.self4j, and then get logger, and then pass a name of the class, that is Kafka producer, and then class. Okay, now we have created a logger instance. So let's use this logger instance to log this message. So here just use info method. So within an info method, let's use string dot format method, and then pass a message as something like message sent, and then let's use a placeholder and then message. Okay, so this will basically log message sent followed by the message. Okay, now we have created Kafka producer, which will use Kafka template to send a message to the topic. The topic name is Java guides. All right, great. So let me rerun the Spring Boot application and let's see any errors or exceptions. So here you can see in a console, Spring Boot application is running in a default Tomcat server on port 8080. Well, if you can just scroll up, and here you can see these are the all default properties and values provided by Kafka. Okay, we are not going to change anything, so we are going to rely on these default properties provided by Kafka admin client. All right, so in this lecture basically we have created a Kafka producer which use Kafka template to send a message to the Kafka topic. Okay, great. I will see you in the next lecture. Hi, welcome back. In this lecture, we'll create a REST API to send a message to the Kafka producer. Well, if you can see the Kafka architecture over here, in previous lecture we have created Kafka producer, right? In this lecture, we'll create a REST API to send a message to the Kafka producer, and then Kafka producer will send that message to the Kafka topic. Okay, let's head over to the IntelliJ idea and let's create one simple REST API to send a message from the client. Well, let me create a new package and let me call it as controller. And within a controller package, let's create a class and let's name it as message controller. Hit enter and let's annotate this controller class with @rest controller annotation in order to make this class as a Spring MVC REST controller. And let's also use @request mapping annotation to define the base URL for the REST API. So here I am going to use /API/v1/Kafka. Well, within a message controller, we are going to create a REST endpoint. So before that, we need to inject the Kafka producer. So let's say private and then Kafka producer. So we are going to use a constructor based dependency injection in order to inject Kafka producer. So let me create a constructor over here, generate constructor, and okay. So here we are not going to use @auto-wide annotation, okay, because if Spring Bean has only one constructor, then we can avoid using @auto-wide annotation. Okay, you can use @auto-wide annotation, but Spring 4.2 onwards we can ignore this annotation if Spring Bean contains only one parameterized constructor. So you can see in our case this message controller Spring Bean has only one parameterized constructor. So Spring IOC will by default inject this dependency. Okay, great. Now let's create a REST endpoint. So let's say public, and then let's use a response entity as a response type, and let's pass string as a type, and then let's say send message, or let's say publish as the method name, and then string message as the method parameter. And let's annotate this method with @get mapping annotation, and let's pass the URI something like publish. And then in order to get the value from the URL, we are going to use query parameters. So let's use @request param annotation in order to get the value from the query parameter, and let's provide a key as a message. Okay, so we are going to basically retrieve a value from the query parameter. That's why we are using here @request param annotation, and the key that we are going to define in a query parameter is message. Okay, something like this. So let me create a REST endpoint URL for you. Let's say http://API/v1/Kafka/publish, and then in order to define the query parameter we use question mark followed by the query parameter key, that is message, and then we provide a value, let's say hello world. Okay, so this is the message that we have provided over here as a key. Okay, and in Spring we use @request param annotation to retrieve value of this query parameter. Okay, and that value will be stored in this message. All right, great. Now let's go and let's call the Kafka producer in order to pass this message. So here I am going to call Kafka producer and then call its method send message, and then pass message to it, and simply return response entity dot okay, and in a response just pass like message sent to the topic, something like this. That's it. Now we have built a simple REST endpoint that will publish a message to the Kafka producer, and Kafka producer internally use Kafka template to send that message to the Kafka topic. Now let's run the Spring Boot application, and let's call this REST API to send a message to the Kafka topic. Well, let me run the Spring Boot application from here, and you can see Spring Boot application is running on embedded Tomcat server on port 8080. Now let's go to the browser, and from the IntelliJ IDEA, so let me simply copy this URL and paste it in a browser and hit enter, and there we go. Well, REST API has returned the response message sent to the topic. It means that the REST API that we have built to send a message to the Kafka topic is working as expected, right? Now let's go and let's verify whether this hello world message is successfully sent to the Kafka topic or not. In order to do that, let's go to Kafka quick start page over here and let's go to the steps. So let's go to step 3, create a topic to store your events. Well, we have already created a topic in a Kafka cluster using Spring Boot application. Let's move to the next step, write some events to the topic. Well, we have already created a Kafka producer and we have already created a simple REST API to send a message to the topic. So let's move to the next step, read the events or messages from the topic. Well, we use this command in order to verify whether the message is returned to the Kafka topic or not. Okay, so this is basically a Kafka provided sh file. It acts as basically a consumer. So let me simply copy this command and let me execute in a terminal so that we can able to see whatever the messages that we have sent to the Kafka topic. So let's go to terminal again, and in a terminal I am going to open a new cell. If you are using a Windows, then make sure that you open a Windows a command prompt. So just go to downloads folder. So we have Kafka in a downloads folder, right? So cd downloads, cd Kafka, and from here we simply paste the command. Well, within this command we need to change the topic name. Right here you can see the topic name quick start -events, but we have given a topic name as Java Guides, right? So let's go ahead and let's change this topic name to Java Guides and hit enter, and here you can see, so these are the messages that are there in a Kafka topic. Okay, and we have sent hello world message, right? So now we can able to read that hello world message from the Kafka topic. Well, let me send one more message. So let's say test Kafka message in a topic, something like this, and hit enter, and let's go to terminal, and there we go, test Kafka message in a topic. So it means that Kafka producer has sent a message to the Kafka topic, and Kafka consumer consumes that message from the Kafka topic. Well, let's go ahead and let's send one more message to the topic. Let's say Kafka topic 123, something like that, and go back to terminal, and you can able to see Kafka topic 123 is successfully read from the Kafka topic. So this Kafka console consumer.sh file, so this sh file we can use to simply read the events or messages from the Kafka topic. Okay, now we have seen how to read events or messages from the Kafka topic by using command line. In next lecture we will create a Kafka consumer to consume the message from the Kafka topic. Alright, I will see you in the next lecture. Hi, welcome back. In this lecture we will create a Kafka consumer to consume messages from the Kafka topic. Well, if you can see our Kafka architecture, so far we have created a Kafka producer which will send a message to the Kafka topic. Now in this lecture we will create a Kafka consumer which will consume a message from the particular Kafka topic. Well, let's head over to the IntelliJ IDEA and let's write the Java code to create a Kafka consumer. Well, let's go to Kafka package, right click on it, new, and then choose Java class, and let's give class name as Kafka consumer. Alright, hit enter, and let's go ahead and let's annotate this class with add service annotation to make this class as a Spring Bean. So within this class we are going to create a subscriber method which will subscribe to the topic. So we are going to basically use Kafka listener annotation from Spring Kafka library to listen or to subscribe to the topic. So let's first create the method, and then we're going to use annotation to subscribe to the topic. So let's say public, and the return type of the method is wide, and let's say consume is the method name, and we're going to basically consume the type string, right? Message type string. So let's say string message, and then let's annotate this method with @Kafka listener annotation, and make sure that you choose Kafka listener annotation from spring framework.kafka.annotation. okay, so Spring basically provide this annotation to subscribe to the topic. Well, let's call this annotation over here, and this annotation has a lot of properties. So we're going to use topics attribute to provide a topic. So let's say the topic name is Java Guides, right? Now this consume method, it acts as a subscriber, and it's subscribed to the Java Guides Kafka topic. Well, whenever Kafka producer will send a message to the Kafka topic, then this subscriber method will receive that message from this Java Guides Kafka topic. Well, there can be any number of subscribers. Okay, in our example, to keep it simple, we have only one consume subscriber method. It subscribed to the Kafka Java Guides topic. Okay, great. We have provided a consumer group ID, right? So we need to also provide a consumer group ID to this annotation. So in order to do that, we're gonna call group ID, and then we have given a consumer group ID as my group, right? So if you can open application.properties file, we have given a consumer group ID as a my group, right? So this my group ID we have to provide in the annotation. All right, perfect. Now what we're going to do is we're going to have a logger over here, and then we log the messages. So let's say private static final, and then logger from self4j library, and then there should be a logger, and then logger factory, get logger, and then dot class. All right, now let's use this logger to log the messages. Okay, logger dot info, and then let's use string dot format method, and let's say message received, and then let's put the placeholder %s, and then pass the message. Okay, well, whenever Kafka producer will send a message to the Kafka topic, then this consumer will consume that message from the Kafka topic, and it will print to the console by using this log statement. All right, it's pretty simple. Now let's go and let's run our Spring Boot application, and let's verify how this Kafka consumer will work. So let me stop the existing server, and let me start the server again. All right, and here you can see message received. So right now in a Kafka topic we have this number of messages, right? Now we have written a Kafka consumer, so we can able to see that all these messages are consumed by this Kafka consumer, and same messages were printed in a console by using this log statement, message received followed by message. Now let's go ahead and let's use a REST API to send a message to the topic using Kafka producer, and we'll see how this Kafka consumer will consume that message. Well, let me go to the browser, and let me send a message using this REST API. Let's say hello Kafka, hit enter. Well, let's go to IntelliJ IDEA, and let's see the logs, and there we go, message received, hello Kafka. Okay, so let me send one more message. Let's say hello Spring Boot Kafka, and here you can see the log statement, message received, hello Spring Boot Kafka. It means that the Kafka consumer that we have written is working as expected. This is how basically we write a Kafka producer and consumer to send a message to the topic and consume that message from the topic. In this lecture, we'll configure Kafka producer and consumer for JSON serializer and deserializer. In previous couple of lectures, we have used message of type string format for the communication, right? So Kafka producer will basically produce the message of type string and it will write to the Kafka topic, and then Kafka consumer will consume that string message from the Kafka topic. Well, sometime we may have a requirement to write a Java object as a JSON to the Kafka topic, and consumer will consume that JSON and then convert it into Java object, right? Well, in next upcoming lectures we will see how to send and receive Java object as a JSON byte array to and from Apache Kafka. Well, Apache Kafka stores and transports byte array. There are a number of built-in serializers and deserializers, but it does not include any for JSON. Therefore, Spring Kafka created a JSON serializer and JSON deserializer, which we can use to convert Java objects to and from a JSON. Well, Spring Kafka it provides a JSON serializer and JSON deserializer. So we can use these two classes to convert Java object into JSON and JSON into Java object. We will send a Java object as a JSON byte array to Kafka topic using JSON serializer. Afterward, we will configure how to receive a JSON byte array and automatically convert it into Java object using JSON deserializer. Well, let's head over to the IntelliJ IDEA and let's change application.properties file to configure JSON serializer and deserializer for Kafka producer and consumer. Well, let me go to the IntelliJ IDEA. Let's go to application.properties file over here. So here you can see we have used string deserializer and string serializer classes to serialize and deserialize message key, right? So we are going to keep string deserializer and string serializer classes from Kafka library for this message key. We are not going to change the deserializer and serializer classes for this key. We are going to only change the message value. Okay, so here you can see right now we have string deserializer class from Kafka library to deserialize a value for this consumer. So let's go ahead and let's change it. So let's use JSON deserializer from Spring Kafka library. So let me comment it out this, and here I'm going to type the property spring dot Kafka dot consumer dot value hyphen d serializer, and then the value is org.springframework.kafka.support.serializer.json deserializer. Okay, now we are using JSON deserializer class from Spring provided library, not from Kafka library. Okay, so this JSON deserializer is basically created by Spring Kafka library, not from Kafka library. Okay, now we have configured JSON deserializer for this Kafka consumer. So Kafka consumer will basically convert JSON byte array into Java object by using this JSON deserializer. Now let's go ahead and let's see how to configure JSON serializer class for this Kafka producer. So right now we are using string serializer class to serialize the value from the Kafka library, right? So let me simply comment it out this, and let me write the property spring dot Kafka dot producer dot value hyphen serializer, and then type the value org dot spring framework dot Kafka dot support dot serializer dot and then JSON serializer. Okay, it means that this Kafka producer will basically convert Java object into JSON and then it will write to the Kafka topic. Alright, now we have configured Kafka consumer and Kafka producer for JSON deserializer and JSON serializer. Alright, great. Well, in a Kafka consumer we can also configure one more property, that is spring.kafka.consumer.properties.spring.json.trusted.package is equal to star. It means that Kafka consumer can deserialize all the classes from this package. Okay, here star meaning all the classes from this package. Alright, perfect. Now we have configured Kafka consumer and producer for JSON deserializer and JSON serializer. Alright, in next lecture we'll create a simple Pojo class that we can write to the Kafka topic. Alright, I will see you in the next lecture. Hi, welcome back. In this lecture we'll create a simple Pojo class, that is user class, to serialize and deserialize. Well, basically we are going to create a user class and we'll send and receive user object to and from a Kafka topic, and we are going to use Spring Kafka provided JSON serializer and JSON deserializer classes to convert JSON into Java object into JSON. Alright, let's head over to the IntelliJ IDEA and let's create a simple user class. Well, let me create a new package over here and let me call it as payload, or you can give any package name that you want, something like model or beans or DTO. So I'm going to use payload here, and within this package we're going to create a class. Let's call it as user, and let's go ahead and let's define few instance variables, something like private int id and then private string first name. Alright, and then private string last name, and then let's go ahead and let's create a getter setter methods to access these private fields. So right click, generate, and then choose getter setter methods, and then choose all these instance variables, and then click on OK. So this will create a getter setter methods to access the private instance variables. And let's go and let's also create a toString method. Perfect. Now we have created a simple Pojo class, that is user class, for serialize and deserialize. In next lecture we will create a Kafka producer to produce JSON message. Alright, I will see you in the next lecture. Hi, welcome back. In this lecture we will create a Kafka producer to produce JSON message using Spring Kafka library. Well, let's head over to the IntelliJ IDEA and let's go and let's create a new Kafka producer to produce a JSON message. So we have already a Kafka producer, but it will produce the string message, right? So we'll create a separate Kafka producer to produce a JSON message. So right click on the Kafka package, new, and then choose Java class, and let's say JSON Kafka producer. Hit enter, and let's annotate this class with @service annotation to make this class as a Spring Bean. Alright, now let's configure the logger. Okay, so private static final, and then use logger from self4j, and then this should be a logger equal to logger factory, and then call get logger API, and then pass JSON Kafka producer dot class. Okay, perfect. Now let's go and let's inject Kafka template to send a JSON message to the Kafka topic. Well, here let's say private and then Kafka template. So Kafka template is from Spring Framework.kafka.core, and this is the generic. So we are going to pass key as a string type and value as a user. Well, we are going to pass user object as a byte array to the Kafka topic, right? That's why we are going to use user class as a value type here, and then Kafka template. So let's use constructor based dependency injection in order to inject Kafka template. So let's generate a constructor, and again we don't have to use @auto annotation over here, because Spring Framework will automatically inject this dependency whenever this bin will have only one parameterized constructor. So let's ignore at word annotation over here. Okay, now let's create a method and let's call it as send message, and in this case we need to pass a user object as a parameter. Let's say user and then data. Alright, well, within a send message method we are going to create a message that we are going to write to the Kafka topic, right? So here let's say message, and make sure that you choose message class from org.springframework.messaging package, and then we need to pass the type to this message class, that is user, and this is a message, and let's use a message builder. So make sure that you choose message builder from org.springframework.messaging.support package, and then let's use its method, that is with payload method, and then pass user object as a argument, and then call set header. So basically we are going to set a topic name in header, right? That's why let's call set header over here, and then Kafka headers, right? Kafka headers, and then topic name. So let's call topic here, and then pass second argument as a topic name. Topic name is Java Guides, isn't it? And next let's call a build method to build the message object. Now we have created a message, isn't it? Next let's go ahead and let's send this message using Kafka template. So let's say Kafka template dot send method, and here you can see we need to pass this message, right? So let's call this send method and then pass message. Perfect. Now we have created a message object and we have sent using send method of Kafka template object. So we have created a logger, but we haven't logged this user object yet, right? So let's go ahead and let's put the logger statement here in order to log the user object. So logger.info, and then use string dot format, and then let's say message sent, and then put the placeholder, and then pass data dot toString method. Okay, so we have created toString method in a user class, right? So that is what we are calling here. Now we have created Kafka producer to produce the JSON message and send that JSON message to the Kafka topic. Now let's run the Spring Boot application, and here you can see Spring Boot application is successfully running on Tomcat server on port 8080, and also you can see my group is the consumer group name, and by default Kafka provides the partition name, that is Java Guides -0. Alright, it means that the Kafka producer that we have written for JSON serializer is working as expected. Okay, in next lecture we'll create a simple REST endpoint to send a JSON message from the client. Alright, I will see you in the next lecture. Hi, welcome back. In this lecture we'll create a REST API to send a JSON object from the client. Well, if you can see this Kafka architecture over here, in previous lecture we have created a Kafka producer for JSON serializer, right? In this lecture we will create a simple REST API that will send a JSON object in a request, and then Kafka producer will basically send that JSON object to the Kafka topic. Alright, great. Let's head over to the IntelliJ IDEA. Well, head over to the controller package, right click on the controller package, new, and then choose Java class, and let's give class name as JSON message controller. Hit enter, and let's annotate this class with @REST controller annotation, and let's use one more annotation, that is @request mapping annotation, and then pass the base URL, that is API/v1/Kafka. Alright, and let's go and let's inject Kafka producer, that is JSON Kafka producer. So private and then JSON Kafka producer, and this is the Kafka producer, and let's use constructor based dependency injection. So let's generate the constructor. So again, we don't have to use @atoid annotation here because this is the Spring Bean. It has only one single parameterized constructor. So Spring will automatically take care of injecting this dependency. Now next, create a method over here, public, and then provide a return type as a response entity, and then pass string as a type. Okay, and then let's say the method name is something like publish, and then pass user object as a parameter. Okay, perfect. And let's annotate this method with @post pumping annotation. So this will basically handle HTTP post request, and then provide the URL, that is publish, and let's use @request body annotation to automatically convert JSON into Java object. And then let's call Kafka producer and then its method send message, and then pass user object to it, and then simply return response entity dot okay message sent to Kafka topic. Let's say JSON message. Instead of message, let's call JSON message. Okay, perfect. Now we have created a simple REST endpoint which will handle HTTP post request, and it will process the JSON object from the HTTP request. Okay, perfect. Now what we'll do, we'll run the Spring Boot application, and let's see how the Kafka producer will send a JSON message to the Kafka topic. So let me stop the existing server and let me restart the Spring Boot application. And here you can see Spring Boot application is up and running in an embedded Tomcat server on port 8080. Let's go and let's use Postman REST client to call the REST API. So I'm going to open the Postman client over here and choose HTTP post method, and then type HTTP localhost and then 8080/API/v1/Kafka/publish. Okay, so this is the URL, and then we need to pass the JSON object in a HTTP request, right? So go to headers, not headers, go to body and then raw, and then choose content type as a JSON, and in a body we need to pass the user JSON object, right? So let's have ID. So let's say ID equal to 1, ID colon 1, and then user first name, let's say Ramesh, and then user last name, let's say Fadhari. Okay, perfect. Now let's go and let's hit a send button over here, and there we go, we got a success response, that is 200. Okay, and the message is JSON message sent to the Kafka topic. Now let's go ahead and let's see whether this JSON message has sent to the Kafka topic or not. So we can verify it from the command line. So you can just type this command, okay, and you can able to see this command will basically consume the message from the Kafka topic. And here you can see this is the JSON object from the Kafka topic. It means that we have successfully written a Kafka producer to produce the JSON message and sent to the Kafka topic, isn't it? Now let's head over to the IntelliJ IDEA, and if you go to console, you can able to see there is a exception. So this Kafka consumer we have created in one of the previous lecture, right? And this Kafka consumer has subscribed to the topic Java Guides, and this Java Guides topic has a message of type string, but we have just sent a JSON, right? And this consume method has a message of type string. This should be a user, right? But it has a string type. That's why you can able to see the error in a console. So what we can do is we can basically create a one more topic to send only the JSON messages. So go to Kafka topic, the Kafka topic config, and here let's create a one more topic. So let me simply copy this bin and paste it here, and let's say Java guides underscore JSON, and let's change the name as well, that is Java guide JSON topic. Now let's head over to the JSON Kafka producer, and let's change the topic name from Java guides to Java guides underscore JSON. Now this JSON Kafka producer will send the message to this topic, that is Java guides underscore JSON topic. Okay, now let's run the Spring Boot application and let's see how this works. Now let me run the Spring Boot project, and our Spring Boot application is up and running in an embedded Tomcat server on port 8080. Now let's send the JSON, let's call this REST API to send a JSON object in a request. So let me call this send button, and there we go. Now let's go to command line over here, and here what we'll do, we'll simply pass the topic name, that is Java guides underscore JSON. Hit enter, and there we go. You can able to see this topic, that is Java guides underscore JSON topic, contains this JSON message. Okay, now let's head over to the IntelliJ IDEA, and in a console you can able to see there are no errors or no exceptions. It means that we have created a separate Kafka topic to store the JSON messages. Okay, in next lecture we will create a Kafka consumer to consume the JSON message, and it will automatically convert JSON into Java object. Alright, great. I will see you in the next lecture. Hi, welcome back. In this lecture we will create a Kafka consumer to consume JSON message. Well, let's go to IntelliJ IDEA and go to Kafka package, right click on it, new, and then choose Java class, and let's give class name as JSON Kafka consumer, and hit enter, and let's annotate this class with @service annotation, and let's have a logger object here, private static final, and then logger from self4j, and then logger equal to logger factory, and then get logger API, and then pass class name, that is JSON Kafka consumer dot class. Now we have a logger instance. Let's go ahead and let's create the method over here. Let's say public void, and let's give method name as consume, and in this case we need to pass user object as a method parameter. Okay, perfect. In order to subscribe this method to the topic, we have to use annotation, that is Kafka listener annotation. So make sure that you choose Kafka listener annotation from org.springframework.kafka.annotation package, and then we need to pass the topic name. So in this case we are going to use topic, that is Java guides underscore JSON, and along with that we need to also pass the group ID. So we have a group ID as my group, right? Perfect. So what we can do is we can simply log this user object. So in order to do that, let's say logger.info, this should be a logger object, and then call info method, and then let's say string, and then call format method, and then pass message something like JSON message received, and then placeholder, and then pass user dot toString. Perfect. Now we have created Kafka consumer to consume the JSON message. Alright, so basically this JSON deserializer which is provided by Spring Kafka, it will basically convert a JSON into user object, and that user object we have simply printed using this log statement over here. Right, now what we can do is we can run the Spring Boot application, and we'll verify how this Kafka consumer will consume a JSON, and it will convert into JSON into user object. So let me run the Spring Boot project, and there we go. Spring Boot application is up and running on Tomcat server, and you can able to see JSON message received. It means the Kafka consumer that we have returned to consume JSON message is working as expected, right? Now let's go and let's call the REST API to see how the JSON message is sent to the Kafka topic and how it should be consumed. So here what I'm going to do is I'm going to change the JSON object, let's say ID2, and then first name is something like Tom, and then last name let's say Cruz, and hit send button and go to the console over here and let's verify the log statement. So just go to the bottom, just scroll down and go to the bottom, and there we go, JSON message received, first name Tom and last name Cruz. Okay, so let's see one more message, let's say John and last name Sina, and hit send button, and let's go to terminal, and there we go. In a terminal also you can able to see there are 3 JSON messages in the Java guides underscore JSON Kafka topic, and you can also see that message printed in the console. There we go, user ID 3, first name John, last name Sina. Alright, so this is how basically we use Spring Kafka provided JSON serializer and JSON deserializer classes to send and receive Java object as a JSON byte array to and from Apache Kafka. Okay, so the important configuration is like this. In application properties file, we need to provide JSON deserializer class from Spring Kafka library as a value deserializer. Okay, and JSON serializer class from Spring Kafka library to value serializer property. Well, I hope you understood how to send and receive Java object as a JSON byte array to and from Apache Kafka. Alright, I will see you in the next lecture. Hi, welcome back. In this lecture, we'll take a look into the overview of real world project. Well, basically we are going to develop a real world project to demonstrate the usage of Spring Boot and Apache Kafka. Well, here is our project goal. Well, basically we are going to read a huge amount of real-time stream data from the Wikimedia to the database. Okay, and if you can see the architecture over here, so we are going to create a Kafka producer which will read a real-time stream data from the Wikimedia, and then it will write that data to the Kafka broker, and then we will create a Kafka consumer which will consume the real-time stream data from the Kafka broker, and then it will write to the database. So this is how the workflow for this project. Well, this real world project is the best use case to demonstrate the usage of Apache Kafka, because basically we use Apache Kafka to deal with a large amount of data, right? In this real world project, we are going to see how to create a Kafka producer to read a large amount of real-time stream data from the Wikimedia, and then it will write that data to the Kafka broker, and then we'll see how to write a Kafka consumer to consume that real-time stream data from the Kafka broker, and then it will write to the database. Okay, so this is how the architecture for this real world project. Well, let's head over to this link and let's see how the real-time stream data looks like. So let me go to the browser and let me hit this link in the browser, and you can able to see this is a large amount of data. So whatever the users do the changes in the Wikimedia, that will be retrieved by using this REST API. Well, if you can closely observe this real-time Wikimedia data, it has the events. Okay, so whenever a user make a change in the Wikimedia, that entry will be stored as an event in the Wikimedia server, and by using this REST API we can fetch all the user made recent changes in the Wikimedia. Okay, well, let me show you a couple of demos for this real-time Wikimedia stream data. So here you can see someone has created this user interface. It behind the scene uses real-time Wikimedia stream data. Okay, you can see here the real-time data records are displaying here. So whatever the changes the user made in a Wikimedia, that changes will be reflected over here. and these are the charts, and you can find the real-time data changes in these charts. So another demo example, you can see someone has written the HTML and JavaScript code to create this user interface. Well, this sample demo behind the scene reads real-time Wikimedia stream data, and it will display that data here in a user interface. Well, in this real-time project, we'll see how to use Apache Kafka broker to read the real-time stream data from the Wikimedia and then write to the database. Alright. Well, basically we are going to create two projects, and you can think of these projects as a microservices. Well, first we create a Kafka producer Wikimedia. So this project acts as a Kafka producer which will read a real-time Wikimedia stream data, and it will write that data to the Kafka broker. Next, we will create a Kafka consumer database project which will consume or read a real-time stream data from the Kafka broker, and then it will write that data to the database. Alright, this is how at a high level Spring Boot Kafka project setup looks like. Basically, we are going to create two projects as a microservices. First one is Kafka producer Wikimedia as a microservice 1, and Kafka consumer database as a microservice 2, and we are going to use Apache Kafka as a messaging system to exchange the messages between microservice 1 and microservice 2. Alright, great. I will see you in the next lecture. Hi, welcome back. In this lecture, we'll create Spring Boot project for Wikimedia producer. Well, basically we are going to create a multi-module Maven project. Within that, we create a sub-module. Alright, so first we'll create a Spring Boot project using Spring Initializer, and then we'll import that project in IntelliJ IDEA, and then we'll create sub-modules within that project. So let's go to browser, and in a new tab, just type start.spring.io. This will brings up Spring Initializer. Let's go and let's fill up the project information over here. So here we have two types of project, Maven and Gradle. So let's keep Maven project as selected and choose language Java, and Spring Boot version 2.6.7. So as of now it is 2.6.7, but it may differ in your case. Alright, next let's fill up the project metadata over here. So let me give group as net.java guides, and then artifact something like Spring Boot Kafka real world project, something like this, and this is the description. So name is same as artifact, and description is demo project for Spring Boot and Kafka, and package let's give net.javaguide.springboot. Alright, and packaging let's keep jar. So basically we are going to create a parent Maven parent project, but we need to change the packaging type as a POM, so we'll do it later. As of now, let's select packaging as jar, and Java version let's keep 11 as selected. You can choose Java 8, 11, 17, 18 as per the JDK installation on your machine, but let's keep default, that is Java 11 as selected. Next, let's go to the dependencies section over here. Click on add dependencies, and here we are going to choose Kafka dependency for Spring application. So let's type Spring for Kafka, and there we go. So this is the Spring for Apache Kafka dependency, which will provide support to integrate Apache Kafka in a Spring based applications. So let's choose this dependency. Okay, so this dependency is enough for us. So also let's choose the Lombok dependency to reduce the boilerplate code. So let me choose this dependency. Alright, perfect. If you want to explore, you can go ahead and explore this project by using explore option. So you can just go to pom.xml, and you can just review whatever the dependency that you have added. Okay, we have added Spring for Kafka dependency as well as Lombok dependency. Okay, just close it and go ahead and click on generate button. So this will generate this Spring Boot project as a zip file. Alright, let's open this zip file in a folder, and then let's unzip this file. So let me unzip it. Perfect. Now let's open the IntelliJ IDEA. So I'm going to open the IntelliJ IDEA over here, and here you can see a couple of options: new project, open, get from CVS. So we are going to open the existing project in the IntelliJ IDEA. So let's go ahead and click on open over here, and then let's go to the location where your Spring Boot project is downloaded. So in my case it is downloads folder. So select it and click on open. So this will open up Spring Boot project in the IntelliJ IDEA. Alright. Now we have generated Spring Boot application using Spring Initializer and imported that project in the IntelliJ IDEA. Let's make this Spring Boot project as a multi-module Maven project. Okay, so let's go and let's make the necessary changes to make this project as a multi-module Maven project. So first of all, we need to make this project as a parent project, right? So go to the pom.xml and we need to add a packaging tag over here. So just add a packaging tag and let's give a value as pom. Okay, so whenever we create a multi-module Maven project, we have to provide packaging type as a pom for a parent project. Okay, now we are good to create the sub modules within this parent project. Okay, just save it and just go to this icon here and just load the Maven changes. Okay, now the parent project is ready. Now let's go ahead and let's create a module within this parent project. So right click on this project, new, and then choose module and tick mark this and then click on next and then give module name as Kafka Producer Wikimedia and then click on finish. So this will create a module within this parent project. So you can see as soon as we create a module within this parent project, a pom.xml will be updated. So you can see here, just open the pom.xml of parent project and if you can see this tag over here, modules section will be added in a pom.xml and you can see the module. Okay, so just go ahead and click on this icon to load the Maven changes. Okay, now we have created Kafka Producer Wikimedia module within this parent project. Well, if you can observe this module that we have created within this parent project, this module project is not a Spring Boot project. So let's make this module as a Spring Boot project. So let me quickly create a package and let's name it as net.javaguides.springboot and let's create a Spring Boot main entry point class within this package. Right click, new, and then choose class and let's give class name as Spring Boot Producer Application. Alright, perfect. And let's annotate this class with @Spring Boot Application annotation and let's have a main method within this class. Alright, and within a main method let's call Spring Application and then call static method run method and then just pass Spring Boot Producer Application dot class. Okay, that's it. Now we have created Spring Boot main entry point class for this module. Okay, so if you can run this Spring Boot project, it should work. And there we go. There is no error in a console, right? So what we have done so far, we have created a parent project and within that parent project we have created a module and we have made this module as a Spring Boot project. Okay, so in order to verify this Spring Boot project setup, what we can do is we can go to Maven over here and from here we can just run the command Maven clean install. Okay, and let's see whether the setup is correct or not. And here we go, the Maven build success. It means that the multi-module Maven project that we have created is working as expected. Okay, so one more thing we are missing here, we need to make this Kafka Producer Wikimedia module as a jar file. So go to pom.xml of this module and let me minimize this and here let's give packaging type as a jar. So let's give packaging as a jar for this module and save it and click on this load Maven changes and let's again build this multi-module Maven project. So just run Maven clean install and there we go. It means that the multi-module Maven project that we have created is working as expected. Alright, in next lecture we'll see how to configure Kafka Producer. Alright, I will see you in the next lecture. Hi, welcome back. In previous lecture, we have created a multi-module Marvin project. So basically we have created a parent project. Within that we have created a child project, that is Kafka Producer Wikimedia. So this Kafka Producer Wikimedia project, it acts as a Kafka producer. Now in this lecture, let's go ahead and let's configure Wikimedia producer, and also we'll create a topic within our Spring Boot project. So let's go to IntelliJ IDEA and let's go to this module, that is Kafka Producer Wikimedia, and just expand src and then go to resources folder. So within the resources folder we are going to create a application.properties file. So choose file here and just give file name as application.properties, hit enter. So within this application.properties file we are going to configure a producer. So just type the property spring.kafka.producer dot bootstrap hyphen servers. Well, here we are going to configure this property because we are going to tell Spring Boot that this is the Kafka broker which is running on port 9092. Alright, so whenever we create a Kafka producer, it will read the real-time stream data from the Wikimedia, and then it will connect to the Kafka broker, and then it will write that data to the Kafka broker. Alright, next let's configure key serializer and value serializer for producer. Well, let's type the property spring.kafka.producer.key serializer and then colon org.apache.kafka.common.serialization.string serializer. So similarly, let's configure value serializer class. So let me simply copy this property and paste it over here, and let me change from key to value. Alright, now we have configured key serializer and value serializer classes. Okay, so whenever we develop Kafka producer, so Kafka producer will internally use these serializer classes to serialize the input data. Okay, great. Next we need to create a Kafka topic. Well, go to the main package of this module and right click on the main package, new, and then choose Java class. Let's give class name as Kafka topic config. Alright, and hit enter, and let's annotate this class with @configuration annotation so that Spring will make this class as a Java configuration class. Let's create a bin, Spring bin, within this class. So we are going to basically use Java based configuration to create a Spring bin. So public, and then return type is new topic class from Apache Kafka clients admin package, and then give a method name here as a topic, and let's return object of new topic class. So in order to build this object, we are going to use topic builder from Spring package. Okay, Spring framework.kafka.config package, and then it has a name API. So let's use name API, and let's give topic name as Wikimedia underscore recent change, something like this, and then call build method to build the object. Okay, so you can also create the partition by using partitions here, but I want to keep default partitions that is created by Kafka broker. So let's save this and let's annotate this method with @bin annotation. Perfect. Now we have created a Kafka topic. Okay, great. Well, let me recap what we have done in this lecture. We have created application.properties file. Within this file we have configured key serializer and value serializer classes for the Kafka producer, and we have also mentioned the Kafka broker URL over here. Next we have created a Kafka topic named Wikimedia underscore recent change. Alright, great. In next lecture we will start implementing Wikimedia Kafka producer. Alright, great. I will see you in the next lecture. Hi, welcome back. In this lecture we will start implementing Wikimedia Kafka producer. So let's head over to the IntelliJ IDEA and let's go to the main package. So look at here, we are in a module, not in a parent project. Okay, so go to main package, right click, new, and then choose class. Let's give class name as Wikimedia Changes Producer. Okay, so this is the name we are giving to the Kafka producer. So hit enter, and let's annotate this class with add service annotation from Spring package. So we are going to make this class as a Spring Bean by using add service annotation. Well, within this class, let's first create a logger instance. So let's have private static final and then logger from self4j, and then logger equal to logger factory, and then call get logger method, and then pass this Wikimedia class name here dot class. Perfect, we have created logger to log the messages. Next, let's go ahead and let's inject Kafka template from Spring Kafka library. So we are going to use Kafka template to send a messages to the Kafka broker. So let's first declare a Kafka template, and then we use constructor based dependency injection to inject this Kafka template. So let's pass key value as a string type. Okay, and let's say the object name is Kafka template. Now let's create a constructor. Right click, generate constructor, select this variable, and then click on OK. Now we have created a constructor for this class. Well, whenever Spring finds a single constructor for a Spring Bean, then Spring will inject this dependency. We don't have to basically add auto-wild annotation over here. Alright, so just ignore this annotation. Spring will automatically inject this dependency whenever it will find a single parameterized constructor in a Spring Bean. Okay, great. Next, let's create a method which will read a real-time Wikimedia stream data. So let's create a method like this. The method is public and the return type is void, and the method name something like send a message. Alright, and within this method, let's have a topic name post string topic equal to the topic name we have given Wikimedia underscore recent change. So this is the topic name we have given, right? So let me go to Kafka topic config here, and here you can see, well, this is the topic name that we have given to the Kafka topic. Alright, so let's go back to Wikimedia changes producer over here. Now, in order to read a real-time Wikimedia stream data, we are going to use event source. So here I am going to write the comment to read real-time stream data from Wikimedia, we use event source. Well, in order to create an event source and read the real-time event data from the Wikimedia, we have to use a couple of libraries. So let's go and let's add a couple of libraries. So go to the browser in a new tab, just type OKHTTP event source maven and hit enter, and go ahead and click on this first link and go to 2.5.0 version, and this is the maven dependency that we are going to use, that is OKHTTP hyphen event source. So this is the dependency that we are going to use to create the event source to read the events from the Wikimedia. So let me copy this dependency, go to IntelliJ IDEA and go to pom.xml of this particular module. So we are not going to add this dependency to the parent project. In fact, we are going to add this dependency to the module. Okay, so go to pom.xml of this module and create a dependency section over here, dependencies, and within these dependencies just paste this dependency. Okay, perfect. Now if you can see the data, this data, real-time stream data from the Wikimedia, so it has a JSON, right? So we also need to use JSON libraries in order to deal with this JSON. So just go ahead and search for JSON Marvin, hit enter and go to this first link, okay, and go to this 2.13.2. alright, and just grab this Marvin dependency and go to pom.xml again and simply paste it over here. Now we have added JSON core dependency. Let's also add one more JSON dependency, that is data bind dependency. So go ahead and click on this and choose the latest version and just copy this dependency and go to pom.xml again and just paste it over here. Now we have added these three dependencies, okay. So here this dependency we have added in order to create a event source to read the real-time event data from the Wikimedia, and these two dependencies we have added to deal with the JSON data. Alright, so now if you can see here this icon, so go ahead and click on load Marvin changes icon over here. Well, as soon as we loaded Marvin changes, we got this error, cannot resolve this dependency. Well, basically this OK HTTP hyphen event source. So this dependency needs a transitive dependency. So let's add a transitive dependency for this dependency. So go to browser, go to this Marvin repository and here just type HTTP, OK HTTP, hit enter and go ahead and click on this link. So if you can see the error com.squareup.ok. So this is the dependency we need to add. So go ahead and click on it and just scroll down and click on this 4.9.3. so this is the latest release of this dependency. So go ahead and select this Marvin dependency, just copy it, okay, and just right below here paste this dependency and go ahead and click on this Marvin changes icon. So this will load this dependency from the internet. Now we have added all the required dependencies to the pom.xml file. Now we are good to write the event source code to read the real-time event data from the Wikimedia. Now let's go back to our producer class, that is Wikimedia changes producer. Now we are good to write a event source code which will read a real-time stream data from the Wikimedia. Well, in order to handle the events, we are going to create a separate class, that is Wikimedia change handler. So let me create a class. So right click on the package, new, and then choose Java class, and let's give class name as Wikimedia changes handler. Perfect. And this handler class will implement event handler, event handler interface. Make sure that you choose event handler interface from com.launchdirectly.event source package. Now we need to override a couple of methods from this interface and we need to provide the implementation. So just mouse over on this class and then click on implement methods and then choose all these methods and click on OK. Alright, now in this class we need to only implement on message method. Okay, so these other methods like on open, on closed, on comment, on error, so these are the methods we are not going to implement because these are the methods that we are not going to use. We are going to only use on message method. Well, whenever there is a new event in a Wikimedia, then this on message method will be triggered and then it will read that event. Okay, now what we'll do, we'll create a constructor for this class. So before that, let's declare Kafka template and just pass key type as a string, value type as a string, and then Kafka template. And also let's declare one string variable. It takes a topic value. Okay, perfect. Now let's create a parameterized constructor. Right click, generate constructor, and select these two variables and then click on OK. Now we have parameterized constructor, and these two parameters we pass whenever we create an instance of this class. Alright, perfect. Now just save it and let's go to on message method. So within our on message method, we are going to basically call the Kafka template. So before that, here I'm going to add a logger, private static final, and then logger. So logger from shell4j, and then this should be a logger instance, and then logger factory dot get logger, and then pass the class name Wikimedia changes handler dot class. Perfect. So go to on message method over here and just add the logger statement. So logger dot info, and then pass the message, let's say string dot format, and type the message something like event data, something like this, and then placeholder, that is %s, and then pass the message. So let's say message event dot get data. Okay, now we have added a logger statement to log the messages. Now let's go and let's use Kafka template to send the event to the topic. So let's say Kafka template dot call send method. So you can see here there are a lot of overloaded send methods. We are going to call appropriate one. So let's choose second one. It takes a topic, so go ahead and call this second one, and then pass first argument as a topic, second argument as message event dot get data. Okay, perfect. Now we have created Wikimedia changes handler. So this will basically trigger whenever there is a new event in a Wikimedia. So basically, if you can see here, we have implemented on message method, right? So whenever there is a new event in a Wikimedia, then this handler will be triggered, and this within this handler method, this on message method will be called, and within this on message method we have written the logic to send this message to the topic using Kafka template provided send method. Okay, it's pretty simple. Now let's go back to our producer class, that is Wikimedia changes producer. So within this producer we are going to call this Wikimedia changes handler class. Let's create a event handler object. So let's type event handler. Make sure that you choose event handler from com.launchdarkly.event source package, and then this should be a event handler equal to new, and then call the implementation class, that is Wikimedia changes handler, and then pass first parameter as a Kafka template, second parameter as a topic. Perfect. Now we have created an event handler. Next we need to define the event source URL, that is REST API URL. So let me simply copy that URL from here. So this is the REST API URL. It provides real-time Wikimedia stream data, right? So let me copy this link and let me pass here. Perfect. Now we need to pass this URL to the event source. Next we need to create a event source which will basically connect to the source, that is Wikimedia source, and it will read all the event data. So let's create a event source, and make sure that you choose event source from com.launchdarkly.event source package, and then call builder. So first we need to create a builder, event source builder, and then we create a event source object from the event source builder. Next new, and then event source dot builder, and then pass event handler as a first parameter, second parameter as the URI. So just call URI dot create and then pass URL. Perfect. Now we have created event source builder. Now let's create a event source object from this builder. So let's say event source, and then event source equal to builder dot build method. Perfect. We have created event source object. Well, if you can see the internal implementation of event handler internally uses executor service to create the threads. Okay, so now what we need to do is we need to start this event source in a separate thread. So just call event source dot start. Okay, perfect. I am going to provide the sleep for 10 minutes. So just call minutes and then call sleep and then 10 minutes. Okay, after 10 minutes this should be stopped. Okay, so let me see what is the error here. So this should handle the exception. Okay, perfect. Now what we have done, basically we have created a Wikimedia changes handler. So this handler will be triggered whenever there is an event in a Wikimedia, and then this event source will basically connect to the source, that is Wikimedia source, and the source URL is this, and then this event source will pull all the real-time stream data from this source, and then it will trigger the respective handler. Okay, and then within a handler we have written a code to send that event to the topic, isn't it? Well, in order to run this Wikimedia changes producer, we need to call send message method, right? So just go to main entry point class of this project. So this is the main entry point class, that is Spring Boot main entry point class. So let's implement command line runner interface. It provides a run method. So this run method will be executed whenever this application gets started. So here what I am going to do is I am going to inject private Wikimedia changes producer, and let's use at a toward annotation. Now we have injected this producer, so just call its send message method, right? So whenever we run this Spring Boot application by using this main entry point class, then this object will be instantiated, and then it will call its method, that is send message method. Now let's go and let's try it. So let's run the Spring Boot application and let's see how this producer works. Well, you can see in the console we haven't started the Kafka broker. If the Kafka broker is not running in a local machine, then you will get this kind of warning messages. So let's go and let's run the Zookeeper service as well as Kafka broker. Well, let me open the terminal and let me start the Zookeeper service as well as Kafka broker service. Well, I am using Mac, so I am going to open the terminal, but if you are using Windows, then make sure that you open the command prompt. So let me slightly maximize it and let me zoom it. Okay, so we have Kafka folder in downloads folder, so let me first go into downloads folder and then Kafka, and then we need to execute the command. So let's say in order to run the Zookeeper, we need to trigger this command, that is bin/zookeeper-server-start.sh, and then we need to pass this properties file. Just hit enter. Now our Zookeeper service is up and running in local machine. Similarly, let's go ahead and let's start Kafka broker service. So in order to do that, just open the new cell, go to cell, new window. If you are using Windows, then make sure that you should open a new command prompt. So let me a little bit maximize it, and then let me slightly zoom it, and let me go into Kafka folder. Perfect. And let me run the command. Well, in order to run the Kafka broker, we need to run this command bin/kafka-server-start.sh, and then we need to pass this server.properties file. Alright, so hit enter. Now our Kafka broker is up and running on port 9092. Well, in order to confirm whether the Kafka broker is running or not, you can just see this log. Recorded new controller, from now on will use broker localhost 9092. Once you got this log, then you can sure that your Kafka broker is up and running on port 9092. Alright, now let's go back to our Spring Boot project. Well, let's go and let's rerun the Spring Boot application and let's see how this producer works. So let me start the Spring Boot application, and again it has some error. So let me stop the Spring Boot project and let me check what is the error. So it says cause unexpected error. So what is the error? Let me see. Failed to construct Kafka producer. Well, there should be some issue in Kafka configuration. So let me go to application.properties file and let me check what is missing. So here you can see localhost. So this should be localhost, right? So there is a typo. So let me save this file. Now let's run the Spring Boot application and let's see how this works. And there we go. You can able to see in a console event data is retrieving from the source. You can able to see the log here, event data. So in a Wikimedia changes handler, we have logged this statement, right? Event data followed by the message. It means that the Kafka producer that we have written to retrieve a real-time Wikimedia event data from the Wikimedia is working as expected. You can see a lot of data is retrieving. Okay, so there is basically a huge amount of real-time Wikimedia stream data. Okay, so let me stop this, otherwise this will go infinite. Let me stop the server. Now what we'll do, we'll verify whether the Kafka producer that we have written has sent a real-time stream data to the Kafka topic or not. So in order to verify that, what we can do is we can trigger some command from the command line, and then we can see. Well, basically in next lecture onwards, we'll create a Kafka consumer to read a real-time stream data from the Kafka broker. But in order to verify quickly, we can check, or we can verify from the command line. So go to the terminal and let's open a new cell. And then let me slightly zoom it out, and let me go to the Kafka folder, downloads, and then Kafka, and then just have a command that is bin/Kafka console consumer.sh, and then we need to pass the topic name, right? So let me quickly change the topic name for this command. Now right now the topic name is Java guides underscore JSON, right? So we have given the topic name is Wikimedia underscore recent change. Okay, hit enter, and now here you can able to see, we can see that the consumer is reading a real-time stream data from the Kafka topic, isn't it? Now let's go ahead and let's run our Spring Boot project, and let's see how the Kafka producer will retrieve the real-time stream data from the Wikimedia and how it will write to the Kafka topic, and then we'll see this terminal. So let's go to the Spring Boot project and let's run the Spring Boot project, and you can see the Kafka producer is start reading a real-time stream data from the Wikimedia. And similarly, if you go to terminal, you can see here. Alright, so consumer is reading the events or the real-time stream data from the Kafka topic, isn't it? You can just take a look into the console, as well as you can take a look into the terminal. As soon as the Kafka producer will read the real-time stream data from the Wikimedia and it will write to the Kafka topic, then this consumer will read that data from the Kafka topic and it will print here in a terminal, isn't it? So it means that the Kafka producer to read the real-time stream data from the Wikimedia is working as expected. In next section of the lectures, we'll start implementing Kafka consumer to read this data from the Kafka topic, and then we'll see how we can write that data to the MySQL database. Alright, I will see you in a next section of the lectures. Hi, welcome back. In previous couple of lectures, we have seen how to implement a Wikimedia Kafka producer, which will basically read a real-time event stream data from the Wikimedia and it will write to the Kafka broker, right? In next upcoming lectures, we'll see how to implement Kafka consumer, which will consume that data from the Kafka broker and it will write to the MySQL database. Okay, in this lecture we create a Spring Boot project for Kafka consumer, and then next lecture onwards we'll start implementing Kafka consumer to consume data from the Kafka broker, and we'll also see how to store that data to the MySQL database. Well, let's head over to the IntelliJ idea. Here we have parent project, within that we have module Kafka producer Wikimedia. So let's create one more module. So right click on the parent project, new, and then choose module, and then tick mark this and then click on next, and then let's give module name as Kafka consumer database, something like this, and then click on finish. So this will create this Kafka consumer database module within this parent project. So as soon as we create a module, it will add one entry in a pom.xml of this parent project. So if you can go to pom.xml of this parent project, you can see one entry will be added in a module section, right? So go ahead and click on this load Maven changes icon over here. Okay, now let's make a necessary changes for this module to make this module as a Spring Boot project. So first of all, go to pom.xml file and let's add a packaging type as a jar and save it and click on this load Maven changes button. Next, let's create a main entry point class for this project. So right click on the Java package and new, and then choose package, and let's give package name as net.javagates.springboot. Hit enter, and within this package we are going to create a Spring Boot main entry point class. So right click on this package, new, and then choose Java class. Let's give class name as Spring Boot consumer application, and then hit enter, and let's make this class as a Spring Boot main entry point class. So in order to do that, let's annotate this class with @Spring Boot application annotation, and then within this class let's create a main method. Alright, and within a main method let's call Spring application dot run method, and then pass Spring Boot consumer application class. Alright, perfect. Now we have created Spring Boot main entry point class. Alright, now this module becomes a Spring Boot project. Okay, now we are good to create a Kafka consumer. So before that, let's run this project and let's verify this setup is correct or not. So in order to do that, go to the Maven here and then click on this execute Maven icon over here, and then here just run Maven clean install command, and there we go. Well, look at here, Spring Boot Kafka real world project is the parent project. Within that we have Kafka producer Wikimedia, Kafka consumer database. So these are the two modules within this parent project, and all these projects are build success. It means the module that just we have created under this parent project is working as expected. Okay, great. In next lecture we will configure Kafka consumer in application.properties file. Alright, I will see you in the next lecture. Hi, welcome back. In previous lecture we have created a Spring Boot project for Kafka consumer. In this lecture we will configure Kafka consumer in application.properties file. So let's go to IntelliJ IDEA and just expand this Kafka consumer database module. Okay, so make sure that you are in a right project. So go to main, and then within main we have resources folder. Within a resources folder we are going to create application.properties file. So right click on this folder, new, and then choose file, and let's call this file as a application.properties. Hit enter. So within this application properties file we are going to configure Kafka consumer details. So first we need to configure Kafka broker URL, that is Kafka broker address. So just type the property spring.kafka.consumer.bootstrap -servers, and then localhost :9092. Well, our Kafka broker is running on port 9092, right? So that is what we have mentioned over here. Next we need to configure a Kafka brook where the Kafka consumer belongs to. In order to do that, let's have property spring.kafka.consumer and then group -id, and then let's give group name something unique name, that is my group, something like this. Okay, now we have provided consumer group, okay, where this Kafka consumer basically belongs to. Next we need to provide the offset. Okay, so in order to do that, let's type the property spring dot Kafka dot consumer dot auto offset reset earliest. Okay, we give earliest as the value to this offset. Next we need to configure deserializer classes, right? So basically we need to configure two deserializer classes, one for key, another for value. So just type the property spring dot Kafka dot consumer dot key deserializer and then org dot Apache dot Kafka dot common dot serialization dot string deserializer. Okay, so this is the deserializer class that basically deserialize the key in a message. So let's similarly do it for value. So let me copy this property, paste it over here, and let me change from key to value. Okay, now we have configured deserializer classes for key and value. Well, basically Kafka consumer will use these deserializer classes to deserialize key and value in a message. Alright, great. In next lecture, we'll implement Kafka consumer to read real-time stream data from the Kafka topic. Alright, I will see you in the next lecture. Hi, welcome back. In previous lecture, we have configured Kafka consumer in our application.properties file, right? In this lecture, we'll implement Kafka consumer to consume a data from the Kafka topic. Well, let's head over to the IntelliJ IDEA and go to the main package. So make sure that you are in a right project. We are going to create a Kafka consumer in a Kafka consumer database project. So go to main package over here, right click on it, new, and then choose Java class. Let's give class name as Kafka database consumer, something like this. Hit enter and let's annotate this class with @service annotation. So this will make this class as a Spring Bean. And then let's go and let's create a logger instance. Let's say private static final logger from self4j and then variable name and then logger factory and then call logger get logger API and then pass class name, that is Kafka database consumer dot class. Perfect. Now we have created logger instance. Next, create a method. Let's say public void and let's give method name as consume and let's annotate this method with @Kafka listener. Well, make sure that you choose Kafka listener annotation from org.springframework.kafka.annotation package. Next, we need to pass topic and group ID to this annotation. So just call topics attribute and then pass the topic name. Well, we have given a topic name as Wikimedia underscore recent change, right? So this is the topic name we have given. Next, we need to also provide the group ID. Well, the group ID that we have given is my group, right? So let's have a group ID over here. So just call group ID attribute and then pass group ID as my group. Okay, perfect. So if you can go to application.properties file, we have given group ID as my group, right? Let's go back to our consumer class and here you can see for this consume method we need to pass the parameter of type string. So let's say event message. Perfect. Now let's log this message. In order to do that, let's use a logger instance and then use info method and then use string provided format method to format the string dot format and then say let's say message received, and then placeholder, and then pass event message. Well, here is a typo. This should be event message received, something like this. Perfect. Now we have implemented Kafka consumer to consume a data from this particular Kafka topic. Okay, now let's run this Kafka consumer and let's see how this works. So in order to run this, what we need to do is we need to just run the Spring Boot this project. So go to main entry point class, alright, and just run this project, and let's see how this how this Kafka consumer will read the data from the Kafka topic. And there we go, you can able to see in a console event message received. So this is the log statement that we have written in a Kafka consumer, right? So let me go to Kafka consumer, and here you can see the statement event message received. Okay, and in a console you can see event message received. It means that the Kafka consumer that we have written to consume the data from the Kafka topic is working as expected, and you can see the event data. Now let's go ahead and let's run Kafka producer and Kafka consumer together, and let's see the result. So in order to run the Kafka producer, so go to Kafka producer Wikimedia project, okay, and run the project. So by using this main entry point class, you can run the project. Now the Kafka producer is start reading the real-time stream data from the Wikimedia, right? Now parallelly, let's run the Kafka consumer. Well, in order to run the Kafka consumer, go to Kafka consumer database project and go to main entry point class, that is Spring Boot consumer application, and just run this project. And you can see in a console there are two tabs. First tab is Spring Boot producer application, second tab is Spring Boot consumer application, and you can see the logs of Spring Boot consumer application event message received. Okay, so parallelly you can see both Kafka producer and Kafka consumer result here. Well, in case of Kafka producer, you can able to see the log event data followed by the event, and in case of Kafka consumer, you can able to see the log event message received followed by the event. Okay, it means that the Kafka producer and Kafka consumer both are working as expected. Okay, great. In next lecture, what we'll do, we'll configure MySQL database in our consumer project, and we will see how to save these events into MySQL database. Alright, great. I will see you in the next lecture. Hi, welcome back. In previous lecture, we have implemented Kafka consumer to consume the data from the Kafka topic. Next, we need to store that data into the database, right? For that, in this lecture, we'll configure MySQL database in a Spring Boot project so that our Spring Boot application can able to connect to the MySQL database, right? So let's head over to the IntelliJ IDEA and let's go to Kafka consumer database project and go to resources folder. Within resources folder, we have application.properties file. So within this application.properties file, we are going to configure MySQL details. Well, before that, first we need to create a database. So let's go to MySQL Workbench, and here just type the SQL statement create database followed by database name, let's say Wikimedia. So Wikimedia is going to be our database name. Let's fire this SQL statement and refresh the schemas, and there we go, Wikimedia database is created. So once we create a database, next we need to add the required dependencies in our Spring Boot project. So basically we need to add Spring Data JP dependency as well as MySQL JDBC driver. So in order to get these dependencies, what we can do is we can go to the start.spring.io website, that is Spring Initializer website, and go to the add dependency section over here and just type Spring JPA. So you will get this option like Spring Data JPA. So go ahead and choose this Spring Data JPA. Next we use MySQL JDBC driver, right? So just type MySQL, you will get MySQL driver over here. Just choose it. Now we have these two dependencies. Okay, so whenever you want to connect your Spring Boot application to the MySQL database, then you have to add these two dependencies. Alright, so Spring Data JPA, by default it uses Hibernate as a JPA provider, and we use Spring Data JPA to simplify the repository layer or a DAO layer. Okay, and we use MySQL driver to connect our Spring Boot application to the database. The database is MySQL database. So go to the explore here option and go to pom.xml and just go ahead and grab these two dependencies. Okay, just copy these two dependencies and go to IntelliJ IDEA and go to pom.xml of kafka-consumer-database project. Okay, so make sure that you are in a right project. So go here in a pom.xml and create the dependency section and just paste these two dependencies. Perfect. And click on this load Maven changes icon over here. Now we have added required dependencies. Okay, now let's go to application.properties file and let's configure MySQL database. Okay, so let me go to resources folder. Within our resources folder we have application.properties file, and within this application.properties file we are going to configure MySQL details. So just type the property spring.data source.url equal to JDBC. So we are going to configure JDBC URL to connect to the MySQL database, right? So JDBC :MySQL and then localhost. Well, we are connecting our Spring Boot application with a local MySQL database, hence localhost, followed by the port of the MySQL server, that is 3306, followed by database name, that is Wikimedia, and then let's configure database username and password. Just type the property spring.data source.username equal to root. Well, in my case I have given a database username as root, but make sure that whatever the database username that you have given, you have to mention over here. So similarly, let's configure database password spring.data source.password equal to mysql@123. Well, whatever the database password you have given to your database, make sure that you have to give here. After that, we need to configure a couple of Hibernate properties. Well, let's first configure Hibernate dilate. So just type the property spring.jpa.properties.hibernate.dilate equal to org.hibernate.dilate.mysql 8 dilate. So make sure that you choose latest dilate. So MySQL 8 is the latest dilate as of now. So this dilate is required to the Hibernate because Hibernate will refer this dilate to create the SQL statement to the respective database vendor. In this case, MySQL is the target database vendor, right? So based on this dilate, Hibernate will basically create the SQL statements. Next, let's configure one more Hibernate property to automatically create the database table. Let's say Spring JPA Hibernate .ddl -auto equal to update. So this will create a database table automatically. Well, we want to also see the Hibernate generated SQL statement in a console, right? For that, let's configure a few more Hibernate properties over here. That is spring.jpa.properties.hibernate.show_SQL equal to true. So this will basically show the SQL statement that is generated by Hibernate in a console, and this spring.jpa.properties.hibernate.use_SQL_comments equal to true. So this property will basically print the comment. Next, spring.jpa.properties.hibernate.format_SQL equal to true. So this property will basically tells Hibernate that whatever the SQL statement that will print in a console should be well formatted. Alright, so these are the few properties that we have to configure in order to connect our Spring Boot application with the MySQL database. Now let's run the Spring Boot application and let's verify whether our Spring Boot application will be able to connect to the MySQL database or not. So go to main entry point class. So make sure that you are in a right project. So open this Kafka consumer database project and go to main entry point class of this project, that is Spring Boot consumer application, and run this class. and you can see there is no errors in a console. It means we have successfully configured MySQL database in our Spring Boot project. Okay, great. In next lecture, we will write a code to save the data into the MySQL database. Alright, I will see you in the next lecture. Hi, welcome back. In previous lecture, we have configured MySQL database in our Spring Boot project. In this lecture, we will see how to save Wikimedia data into MySQL database. Well, we have already written a Kafka consumer which will consume a data from the Kafka topic. Next, we need to save that data into the MySQL database, right? So in this lecture, let's see how to save that Wikimedia data in a database table. Let's head over to the IntelliJ IDEA and let's quickly create a JP entity to store the records into the database table. Well, go to Kafka consumer database project, go to main package, right click, new, and then choose package, and let's give package name as entity. Hit enter. Within entity package, we are going to create a class. Let's give class name as Wikimedia data, something like this. Hit enter, and let's create a fields like private long ID and then private string wiki event data. Alright, so let's keep these two fields. Now let's annotate this class with @entity annotation. So in order to make this class as a JP entity, we have to annotate this class with @entity annotation from JPA. Okay, next let's use @table annotation in order to provide table details. So let's give table name. Let's give table name something like Wikimedia underscore recent change, something like this. Next, let's have a @id annotation to make this field as a primary key. Let's also use @generated value annotation to provide the primary key generation strategy. So let's give identity, and here we need to provide lob annotation because the event data is quite huge, right? So in order to store large data, we can use @lob annotation. Okay, great. Now we need to create a getter setter methods, right? So we have already added a Lombok library. We can leverage Lombok provided annotations to automatically create a getter setter methods. So here I am going to use @getter annotation from Lombok library to create a getters method for these fields, and also let's choose @setter Lombok annotation. Okay, so these two annotation will basically create a getter setter methods for these two private fields. Okay, great. Now what we'll do, we'll create a JP repository, that is Spring Data JP repository for this JP entity. So go to main package, right click, new, and then choose package, and let's give package name as repository. And then within this repository package, we are going to create an interface. Let's call it as Wikimedia data repository. Perfect. And let's extend this interface from JP repository interface and then pass post argument as a entity type, that is Wikimedia data, followed by long as a second argument type. Okay, perfect. Now we have created Spring Data JP repository. So it will basically give crude methods to perform database operations on given entity. Now let's go to Kafka consumer class, that is Kafka database consumer. Here we'll inject Spring Data JP repository and then we'll call respective method to save the event data. So here just declare the Spring Data JPA repository, that is Wikimedia data repository. Let's call it as data repository, and let's use constructor based dependency injection. So let me generate the constructor over here. Okay, we no need to add annotation because this Spring Bean contains only one parameterized constructor. Now we have injected Wikimedia data repository. Okay, now let's go and let's call its save method to save the event message. So here I will create an object of Wikimedia data JP entity, new Wikimedia, and then I am going to set the data, that is event message. Next call data repository dot save method and then pass Wikimedia data. Okay, perfect. Now what we have done, we have injected Wikimedia data repository and then we have called its save method to save this Wikimedia data object. Okay, great. Now let's go ahead and let's run the Spring Boot project and let's see how the data will be stored in a MySQL database. We'll go to main entry point class, that is Spring Boot consumer application. From here just run the Spring Boot project and you can see the consumer Kafka consumer is running. Similarly, let's go ahead and let's run the Kafka producer. So go to Kafka producer class project, that is Kafka producer Wikimedia, and then go to main entry point class, that is Spring Boot producer application, and just run this project. So let me select the Spring Boot producer application over here and just start it. And here you can see two tabs: Spring Boot producer application, Spring Boot consumer application. And Spring Boot producer application, it will basically retrieve the real-time stream data from the Wikimedia, right? And here you can see the logs in the console. And in a Spring Boot consumer application, you can able to see the events are storing in the database. You can see the statements, right? Insert into Wikimedia underscore recent change, and then the value is passing. So let me stop both the instances and we can see the log over here. You can see the insert statement, insert into this table, and this is the data, isn't it? It means that we are successfully storing the Wikimedia data into the database. So let's go to MySQL Workbench and here let's refresh the schemas and go to tables and select rows from the table, and you can able to see Wikimedia event data is successfully stored in this table. Well, let me recap what we have done so far. We have created a multi-module MIME project. Within that, we have created two more projects, one for Kafka producer, another for Kafka consumer. Well, we have created a Kafka producer project to implement Kafka producer to read the real-time stream data from the Wikimedia and write that data to the Kafka topic. And then we have created Kafka consumer project to consume the real-time stream data from the Kafka topic and write that data to the MySQL database. I hope you understood how to use Apache Kafka as a broker to exchange messages between producer and consumer in a Spring Boot project.